What is up, everybody? Welcome to another episode of the AI Marketing Navigator. This is your daily compass in the ever-evolving world of AI marketing. Okay, we have a sleeping baby in the house/studio tonight, so turn up the volume with me if you can, navigators. Sorry if we're a little too quiet today. I'm also going to be taking a little bit different approach today and holding our first AI Marketing Navigator history lesson. I guess the first official history lesson anyway. We have definitely talked about some of these things on the show before, but today, as either an introduction for those who might be new to AI or a refresher to those of you who are familiar, we're going to be doing a brief journey through time through the history of artificial intelligence. And as always, I'm going to try and keep it concise and digestible for all of you. We're going to go through the last 85 years or so of AI in the next 10 minutes, if possible. So buckle up. Like I said, some of you may already be familiar with the things we are going to discuss today. If so, bear with me on this one, because if you are new to AI and have just hopped on board and are doing your best to stay on top of the marketing side of everything and the latest tools, but haven't quite learned any of the history yet, like me before researching and recording this episode, then hopefully you find this helpful. So our journey through time is going to start back in the 1940s when I guess you could say the seeds of AI were planted. A neurophysiologist named Warren McCulloch and a logician, an expert in logic, named Walter Pitts. Sometimes I feel like I'm an expert in logic, but somehow I have to imagine if you've earned the title of logician, you're probably going to be able to win an argument against me. Anyway, McCulloch and Pitt published a paper titled A Logical Calculus of the Ideas, Imminent and Nervous Activity. Super catchy title. But anyway, this proposed a model of artificial neurons, an artificial neural network, essentially, that was based on mathematics, which really laid a foundation for the future of artificial neural networks, which are obviously a key component of machine learning and artificial intelligence. Then, in the 1950s, Alan Turing published his paper, Computing Machinery and Intelligence, which introduced the now famous Turing test for machine intelligence, which continued to ignite and spread interest and discussion about the possibility of creating intelligence within machines. 6 years later, in an event considered by many to be the birth of AI, at least as a field of study, called an event called the Dartmouth Conference, organized by a man named John McCarthy, who was a computer scientist and could be and really is considered one of the founders of artificial intelligence, at least as a moving on to the next decade, the 60s to 70s. We'll just try and break it down decade by decade for you where we can. The 60s brought significant advancements in the field of AI and robotics. Specifically, in 1961, the very first industrial robot, Unimate, started working on an assembly line at GM, General Motors. And this was an early demonstration of the practical applications of AI in an industry. And of course, we've seen no shortage now of robotics recently with many of these humanoid robot programs and systems that we have discussed on the show. In 1965, a computer scientist by the name of Edward Feigenbaum, and of all things, a molecular biologist named Joshua Lederberg, created the first program that was designed to replicate human cognition and thought. And you can consider this probably the first step on our journey to artificial general intelligence, AGI. And they called this an expert system. So where the 60s were a boom for AI, the 70s are actually referred to as an AI winter, particularly due to something called the Lighthill Report, which was a report published by a man named James Lighthill, released in 1973, that harshly criticized the state of AI and the progress since the early 60s. It led to reduced funding and significantly reduced public interest. Fortunately, I guess, if you're pro-AI or an AI optimist, or unfortunately, if you're not, the 80s and 90s saw a resurgence or a bit of a renaissance in AI research. For instance, in 1981, Japan launched an epic fifth-generation computer project, as it was called, dedicating $850 million to building computers that could converse in human language and express some sort of human-level reasoning. In 1997, one of the first major milestones came along during my lifetime when IBM's Deep Blue computer defeated Garry Kasparov, the world chess champion, This not only demonstrated the capabilities of the AI at the time, but reignited the buzz around the field in general. Then in the 2000s and 2010s, we saw the rise and expansion of machine learning. And one key aspect, especially in that, was the rise in computational power and the availability of data, which is so huge in computing and is so necessary to what will allow us to scale these artificial intelligence systems according to the experts. In 2006, Geoffrey Hinton, who was just awarded a Nobel Prize this year, and who has also won a Turing Award, essentially a computer science Nobel Prize. Anyway, in 2006, he coined the term deep learning, and essentially it described a new set of algorithms that sought to allow computers to be able to recognize objects and texts in images and videos. This was really the beginning of the effort for an AI that is capable of what the models we are seeing today are. In 2011, we saw the development of Google Brain, which was a deep neural network that could discover and categorize objects and was actually compared to, in capability and model, a cat's brain. If you want to do a deep dive yourself on all of these moments, quote unquote, through AI history and all the developments that led to where we are today, a good place to start is definitely some of these links in the show notes. You have a lot of reading ahead of you, but it is all fascinating for sure. Anyway, so we are in 2011, and we saw the development of Google Brain, which is now actually merged into Google DeepMind, and we did an episode on that as well. And this was a key step as it demonstrated the potential of deep neural networks to accomplish complex pattern recognition. In 2012, Stanford and Google collaborated and were able to demonstrate an AI performing unsupervised learning. Essentially, this system had learned to recognize pictures of cats from unlabeled YouTube videos, something that we all learned pretty quickly what to do on YouTube, recognizing cat videos. 2015 marked another huge accomplishment when a machine officially outperformed humans in the annual ImageNet challenge. And this is a challenge in which the machine was tasked with recognizing and describing a library of 1,000 images and was able to achieve 97.3% accuracy. So at this point, we've been storming into the 2010s, I guess, which we can consider as the era of big data and big compute and GPUs, graphical processing units, and their importance and necessity in achieving the computational power necessary to train these complex AI models. Essentially, it is just, a computer that is able to handle the necessary workload, the processing workload, and the combination of these GPUs and the extensive amount of big data available in the 2010s quite literally paved the way for our current decade and the rise of LLMs, which, believe it or not, actually snuck in before 2020, in 2017 and earlier. It was actually technically in 2017 that we saw introductions of large language models like BERT and GPT-3. And as we all understand now, the capability to generate human-like text of these LLMs represented a huge, huge leap forward in natural language processing. And so now we're getting into the stuff that we've talked a lot about, these systems that are trained on huge data sets, billions of tokens, billions of words. And it was in 2022, really, when ChatGPT and OpenAI took the world by storm. Especially people in the AI community started to think about what could be possible and how close we actually were to something of a sci-fi-like future. In fact, I think we can go ahead and classify the 2020s, maybe a bit preemptively here, as the age of agentic AI, a new era where these AI agents can autonomously pursue complex goals and workflows with limited to no direct human intervention or supervision. And we've covered many of these recent updates in previous episodes, so definitely check them out and continue to check out the show notes and the links therein. But we've seen very recent developments in agentic AI with the recent computer use capability of the new Claude 3.5 Sonnet, where the AI model can literally autonomously take control of your computer and perform computer tasks, as well as the most recent announcement about Microsoft Copilot features, both just this year in 2024, just in the last few weeks. And it's with the ushering in of these agentic systems that we find ourselves at the current stage of AI that we're at. Literally from research paper to agents, it only took an astonishingly short time of 80 plus years or so. But looking ahead into the future of AI, the potential of these agentic AI systems is so huge and immediately breaks into artificial general intelligence conversation. And by the time that's achieved, we'll hit some pretty sci-fi discussions that we've already done on this show. So, the journey from theoretical papers to agentic systems has been pretty incredible, and I've only hopped on for the last couple of years, as you know, but I'm excited to see what the future holds. It's clearly still in the hands of humans at this point, but more in the hands of AI every day. Okay, that does it for today's episode. If you enjoyed the show or found it useful in any way, please do me a favor and follow on Spotify or subscribe on your podcast platform of choice. A review on top of that would be even more appreciated and it is so super helpful to the show. So until next time, and as always, thanks for joining me and remember to stay curious, stay consistent, and keep navigating forward. Bye.